In this last section in Module 1, we're going to finish up our discussion about exponents for this module. We have one more rule to learn today. It's called the power rule. And then we are just going to practice what we've learned. So, the power rule. Let's first, before we cheat and see what our rule is, hide those guys down here. We're going to figure this out the long way, just like we did with all of the other rules. So I'm going to take my t squared to the fourth. And I'm going to show you that this is t squared times t squared times t squared times t squared, because it's something to the fourth power. But each of those t squareds are really, my parentheses are turning into t's. T times 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 t. Alright? And then if I drop all of my parentheses, get t times 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 t. Alright. And if I count them, 1, 2, 3, 4, 5, 6, 7, 8, I collapse this back down, I get a t to the 8th power. Now, a rule about exponents that I haven't quite mentioned that you should do is make them high and make them small, but make them legible. So that's a t to the 8th. So now I need to figure out what I do with my 2 and my 4 to get my 8. What do I do with a 2 and a 4 to get an 8? I multiply. So this would have been t to the 2 times 4 equals 2 to the 8th. So, as you've probably figured out, my things are all mixed up. I want that one. Okay. The power rules for exponents. If I have a to the m times, or to the n power, I just multiply my two exponents. If I have two things inside with an m out front, I'm going to distribute that power to both of them. Similarly with a product, with a quotient, if I have two things divided with an exponent out front of both of them, I distribute that exponent to both the numerator and the denominator. So, if I want to raise a power to a power, I'm going to multiply my exponents. To raise either a product or a quotient to a power, I'm going to distribute the exponent to everything inside the parentheses. So, we are just going to play with this. And again, I know you can multiply these numbers in your head. That's not the point. The point is making sure you are very clear about which exponent rule you're using. Because I can't tell you how many times in my head I try to multiply 2 times 8 and I come up with 10. Because I accidentally add them. It doesn't mean I don't know what I'm doing, it just means I didn't write it down correctly. So, for maximum effectiveness, we're going to write down that this is y to the 2 times 8, which is y to the 16th. This one would be 3 to the 3 times 2, which would be 3 to the 6th. It's not a ginormous number, but again, I'm not terribly concerned with you evaluating that numerically. I'm more interested in what you're doing with your exponents. Switching colors, 3x to the 4th all to the 3rd power. This exponent is going to distribute to both exponents inside my parentheses. And to make sure I know what's happening, I'm going to put the exponent on the 3 that's actually there. It's actually a 1. So this turns into 3 to the 3rd times x to the 4 times 3. 3 to the 3rd is 27. X to the 4 times 3 gives me an x to the 12th. And that would be my final answer. So, I have a few more to simplify, but I want to remind you of our rule to simplify only one thing at a time. It really, really helps you minimize the errors that you make. So this 4/5 all to the second power is going to give me a 4 to the second power over a 5 to the second power, which gives me a 16 over 25. And this last one, I wind up with a 4 to the third times an m to the 5 times 3 all over an n to the 3 times 3. So I get a 64 m to the 15th over n to the 9th. So that's the product rule that we're using. Now we're going to get ready to throw them all together and see if we can remember which rule to use when. To help us with that, the next page is going to summarize all of the rules that we have. And you have this several times in your book. They're going to be in big purple boxes. Well, if you're using the book that goes with this class. I'm not going to go through them again. They're here. And just know that these are the rules that I'm using to do the simplification that I'm going to do on the next slide. Now I want to reset. So when I go to this next slide, it may seem quite overwhelming. I'm going to write out the steps as minimalistically as possible. So in other words, this is the minimum amount of work you need to show if you would like to be able to receive full credit for all of your thoughts. For those of you who like to take shortcuts. And believe me, I was that student, I know. So this is using a negative exponent plus a quotient rule. So this is y to the negative 10 minus 3, which gives me a y to the negative 13th. And our instructions are to write with positive exponents only. So I need to move this. Remember, this negative exponent is saying it doesn't like where it is in the fraction and it wants to move. So I'm going to have a 1 over y to the 13th. For this next problem, I'm going to have 5 to the negative 4 minus a negative 2 because of my quotient rule. Which is going to give me a 5. Negative 4 minus a negative 2 is a negative 2. Same rule applies here. This is going to become a 1 over 5 to the second power, or a 1 over, that almost turned into 2 to the 5th power, 1 over 25. Now I can tell that I'm going to run out of room as I get closer to that side of the page, so I'm just going to drag him over a little bit. Maybe drag all of these over a little bit. So for my q to the 5th over q to the negative 4th, this is going to be q to the 5 minus negative 4. And when I subtract a negative, I'm going to add. This is going to be q to the 9th. And he's happy just where he is. He's no longer a negative exponent. Let me see if I can divide this up a little bit more clearly. Just so we can see where things begin and where they end. I did put a lot on this slide. It's intended to be an in-class workout. And online it's a little bit different, but that's alright. So for something like 4x to the negative 1 times x to the 5th all over x to the 7th, you really just need to break it down one piece at a time. I know this 4 has nothing that he's going to talk to, so he's going to stay just a 4. And my x, I could actually take care of all at once. I have a negative 1 plus 5, and that whole thing is going to subtract 7. So at this point, it's an order of operations problem. So, when I do this order of operations, I am going to have, with these little boxes, 4x. Now, negative 1 plus 5 is 4. Minus 7 is negative 3. And this x to the negative 3 doesn't like where he is in the fraction. He wants to move down. So this becomes 4 over x to the third. Now let's see about this next one. I have 10 x to the negative 8 y to the fifth over 20 x y to the negative fifth. Some of you are tempted to cancel the y's right away. Don't do it. They don't actually match. What I'm going to do is pick a different color and then break this into 3 different pieces. 10 over 20. I can subtract my exponents right now. X to the negative 8 minus 1, because that's a 1 down there. And then my y is going to be a y to the 5 minus a negative 5. 10 over 20 is 1/2. X to the negative 8 minus 1 is x to the negative 9. And y to the 5 minus negative 5 gives me y to the positive 10. And so when all is said and done, my x to the negative 9th wants to move down into the denominator. And so what I'm left with is a y to the 10th on top, because 1 times y to the 10th is still just y to the 10th, over 2x to the 9th. Now I know that there are a lot of pieces here. The key is just to take each piece one step at a time. For this next one, I would like to be able to select, please. And I'm still okay, well, let's see what happens here. There we go. Alright. Once again, we want to break this into pieces. And I may not have enough room to work this one. I might actually want to change its place with someone else, but we'll see how it goes. So, I have a 6 to the negative 2. That's going to be multiplied by an x to the negative 4 minus 2. And a y to the 10 minus negative 6. And you see how I ran out of room there? So what I'm going to do is I'm actually going to switch places. I am going to pick up my 3/5 to the negative 2 and switch him with this guy. Because I know I can work this one in this much space. So we're running into what I call the airplane dilemma. We're trying to do math in too small of a space. So that's fine. We'll make it work. So 3 to the negative 2 and 5 to the negative 2. This negative exponent is applied to both things in my fraction. So this is going to be a 3 to the negative 2 over 5 to the negative 2. This 3 to the negative 2 doesn't like where it is in the fraction, so it wants to move places. So it's going to be a 1 over 3 to the 2. And this 5 to the negative 2 also doesn't like where it is, so it's going to move places. And it's going to become a 5 squared on top. And this leaves me with 25 over 9. There is a shorter way to do that problem. I'm going to leave you to find it out. Yes, we have a bunch. We have a bunch of these. Let me see where we are time-wise. We're at 15 minutes. I think I am going to stop, and we will come back and we will do some more of these rules of exponents on the next video. And I will give us a little bit more space, and that will be the last video for Mod 1. Congratulations.